Here we are on another test drive. This is an early JK. It's an 07 with a L9H Gen 4 6.2 truck SUV engine. What's really changed over the years isn't so much the powertrain as the way we're doing the swap. 8 years ago, the swap was very different than it is today. So let's talk a little bit about what's changed. Most of the industry is cutting off the original frame brackets that mount the engine mounts for the V6 engine. And we did that for many years. In fact, a lot of companies are still using our design for the hydraulic motor mount. We've gone beyond that now and are using a bolt-in mount. The bolt-in mount offers a lot of advantages. One, there's no fabrication, so you save many hours of not having to cut off, smooth, install, and weld the other mounts. Now this is more important if you're going to do the swap with the body on. Not having to get into that cramped engine compartment and cut and grind is really helpful. Another advantage of the easy mounts is adjustability. Once the motor is in, if you got to move it up, down, sideways, forward, backwards, that's available to you. Third advantage of the easy mounts is it's reversible. You could literally put your V6 back into your JK if you chose. A fourth advantage of the easy mounts is in some countries you're not allowed to modify the frame. So we're not doing any frame modifications with our easy mounts. We're not touching the brake line. It's literally a bolt-in swap. The accessory drive in our current kit uses the JK accessories, and we did that for many years early on. If you mount the air compressor on the passenger lower like GM does, you're getting really close to the frame, depending on the compressor setup you're using. The stock GM Gen 4 compressors are really tight fit. You're most likely going to have to section the frame to get the lines and hoses in and the clearance that you need, and we don't like doing that. You can use a compact compressor like the Sand-Ins, whether it's the 7 Series or the 5 Series, and they will tuck up in there. You're still going to have some tight clearances to the frame. You are running longer AC lines that are custom. And probably the biggest concern is the upper control arm. The JK has the upper control arm on the passenger side, right where the air compressor is. So at full compression, you could smack that compressor. If you have a 4 or 6 inch lift, it's not so much of an issue. As far as the alternator goes, there's not a whole lot of advantage or disadvantage. If you maintain the JK alternator, one, you have it, so you're not buying another one. Two, you can maintain smart charging with the TIPM. The TIPM actually sets the charge goal, the PCM follows it, your light on the dash will work the way it's supposed to, so there's a little bit of an advantage there. Power steering is all over the place, depending if you're using PSC. The Jeep I'm driving right now has a Howe Racing setup, hydraulics. It feels pretty good. We use Redneck Ram, we use Howe, we use PSC, and there's a lot of different configurations. The gearboxes are different where they're ported. Let me say that if you're going to be doing hydraulics and you call up PSC or Redneck Ram, let them know that you have a V8, whether it's a Hemi or an LS, so they can port the box properly. You don't want the ports coming straight out the side and into your motor, so they'll port them out the bottom. You can run an AGR pump in our factory billet accessory drive. You can run PSC, you can run the stock pump. It's very versatile. Be careful with the Camaro, Corvette power steering pumps with hydraulics. In our experience, they just don't work. They work, but you're going to have stutter, high effort steering at low speed. You can mount a JK pump or a PSC pump in the Corvette Camaro accessory drive. Call us for details on that. However, the preferred drive is the JK drive. We're putting the accessories right back where they were. The electrical hookups for the alternator go right back where they were. Power steering lines go right back where they were. That billet accessory drive has been in development for a while, and the LS3 and the truck accessory drives are different. They do share the same AC compressor. If running an LS3 based engine, you need to run the water pump and harmonic balancer off the Camaro, and that's to get the proper offset that we need to run the billet accessory drives. If you buy a GM crate engine 6.2 LS3, it's most likely going to come with a Corvette offset, so you need to change out the water pump and the balancer. We've removed the air conditioning drive off the main belt and put it on its own stretch belt, which GM is doing now. So the belt's down to 80-something inches from 106. Talking about the AC compressor, in the old days GM used a short AC compressor belt, about 36 inches long, with a tensioner. And the tensioner was very low tension, so it would have a tendency to chatter and wear out. There was a lot of issues with the early short AC compressor drive. GM updated that to a stretch belt drive, and while the stretch belt is more difficult to assemble, once it's on there, it should be trouble-free for many, many years with no maintenance and no need to change out the tensioner. Our billet AC bracket mounts the JK AC compressor right back where it was, so there is no more interference with the frame. There is no more worrying about the upper control arm coming up and smacking the AC compressor. You can stuff the front suspension all the way up with no more worries. Moving on with our commitment to keep this swap rationalized is the electronics, and the electronics are really what make the swap work. We could go one of two ways. We can go very bespoke, which means custom build harnesses and hack into CAN networks that will give us the functionality we want, and that will work. We used the Motec module for many years to integrate the GM and the Chrysler side. We are now using our CAN module, and our CAN module now transfers data over the CAN network. There's advantages to the CAN and there's disadvantages to the CAN. The disadvantage is you are now networking essentially two independent CAN networks together through a bridge, and it works very well. In fact, the vehicle I'm driving right now is CAN networked. One of the things that you're going to get with a CAN network is Prindle control. In this JK I'm driving right now, the Prindle is controlled completely through the CAN. You can tell if we look at the Prindle display here, and I'm not sure if you can see it with the sun, but if I were to bump shift it, you can see the current gear display on the Prindle. Now, we didn't have that in our Motec module, and to be honest, I don't give a rat. I don't drive off of what a number says, I drive off of feel and the tachometer. But it is a neat little feature if you're into that. Now here's the critical part of the electronics in our new Easy Kit: factory harnesses. The engine harness is the most critical component in your swap. If the engine computer were the brain, the engine harness is the circulatory and nervous system of your swap. It's the most critical part that makes the swap not only reliable but functional. Manufacturers have spent untold amounts of money over the years to develop the proper engine harness. We're talking power distribution, ground distribution, emissions compliance, failure modes. There's other reasons that we want to run a factory harness over a custom-built hand harness. One is replaceability. If you ever damage your harness, you're going to a dealership, you're buying a new harness and you're plugging it in. And we spend a lot of time integrating the factory harness into this swap. This JK has double throwdown suspension from Evo on it. It's an early 07 JK, but you'll see that it has the same functionality as our newer builds do. The L9H engine we've talked about many times. It's essentially a truck version of the LS3 with VVT. It's a great engine. I get the question a lot, do I want to run a 6.0 or a 6.2? And it really comes down to your need. The advantages of the 6.0 is they're inexpensive and they run on regular gas. They have very good torque, good power. A tune on a 6.0 will make it perform similar, not quite, but similar to a 6.2. A tune on a 6.2 will make it outperform the 6.0. But it really comes down to, do you need the all-aluminum, lightweight, high-compression engine that has over 400 horsepower and requires premium gas? 95% of the time driving around, you're probably going to be happy with a 6.0. You do want to be careful with DOD or AFM engines. AFM engines is a 4-cylinder mode engine. It achieves 4-cylinder mode by deactivating 4 of the cylinders. It does this by dislodging a pin that allows the lifter to collapse and essentially turn that cylinder into an air spring. DOD lifters are susceptible to high oil pressure, so way back when the DOD engines were developed, GM added an additional DOD oil pressure regulator in the oil pan. If you swap out a DOD oil pan for a non-DOD oil pan, like an LS3, an early LS3, you're going to have problems in cold temperature. You're going to overpressurize those lifters, you're going to crunch them. I'm told later on in production, GM installed the DOD lifter in all the engines. The L99 has DOD, so the LS3 just shares that pan and has the regulator. But just be sure that you run the proper oil pan with a DOD regulator or you will have issues. DOD lifters are also susceptible to high RPM. They're not designed to be revved up too high. Now the LT1 has DOD lifters and it does rev up, so there's some technology there, but my experience in the Gen 4 motors is you really want to limit your DOD engine to 6,000 RPM or lower. So if you have an L94, which is essentially the DOD version of this engine, or an L99, or any of the 5.3s, whether it's the LMG or the LC9, get your power down low. And once you get up to 6,000 RPM, these engines aren't pulling hard anyway. The intake is pretty much run out, so there's no reason to spin them up higher than that. If you have to build your motor and you want to rev it up and you want to cam it, ditch the DOD lifters and lifter manifold assembly and convert it to a non-DOD engine. Then you can do whatever you want. You don't have to worry about crunching those lifters. Is there an advantage to DOD? Yes. In a light JK that's not lifted, you're going to see some benefit. The first JK we did over 8 years ago is a LH6. That is an early 2009 5.3 with DOD. In that light JK with 32-inch Rubicon wheels and tires, it's not lifted, it does have a budget boost. We can get 20 miles a gallon on the highway, 16 to 17 around town. A lot of that time we are in DOD, or 4-cylinder mode. My wife doesn't know she's in 4-cylinder mode. You can feel a very slight vibration, but it is in 4-cylinder mode quite a bit, and that Jeep is being benefited by AFM. Now, we're not talking double-digit numbers here. In my opinion, you might be getting 5% better mileage. If you really concentrate and work the throttle so that you stay in DOD, you might get 10%. So that would be in a road like I'm on right now, just cruising along, 50 miles an hour, light load. DOD is going to kick in and it's going to stay in. There's a lot of technology behind DOD. Back in the 80s with the 468 Cadillacs, it didn't really work too well. We didn't have the electronics to modulate the throttle, and it just wasn't the time. But today with modern ultra-fast computers, it does work pretty good. And the Gen 5 motors are reliant on DOD for economy. In a heavy JK, you're not going to see much with DOD. Even if you turn it off, you're probably not going to notice much of a difference. AFM can be annoying if it's constantly engaging and disengaging. And in a heavy JK, if you have 40s, you got 700-800 pounds of wheel of tire that you have to accelerate every time you hit the throttle or decelerate every time you hit the brake. AFM is just not going to stay in. As soon as you touch the throttle, it's going to kick out. So what you're going to feel is this 4-cylinder mode kick into an 8-cylinder mode and then back, and it can be annoying. And not only that, if it's constantly kicking out of AFM, you're not seeing any benefit. In a situation like that, heavy JK, 40s, bumpers, 4-inch lift, just turn DOD off. It's not going to do you any good, and it's just going to annoy you. One other concern with DOD is you do want to run the proper exhaust system. When you go into the 4-cylinder mode, the tone of the engine changes, and it can be annoying and nasally if you don't run the proper muffler and exhaust system. I do recommend you run catalytic converters. Unless you're running a 480 or a 525 horse LS3, run catalytic converters. They're not going to hurt the performance much. They're going to give you better fuel control running upstream and downstream oxygen sensors, and they're going to take a lot of crack out of the exhaust that the muffler's not going to have to. As well as on an AFM motor, they do tend to mellow them out. I don't want to drag this on too long. The L92 came out around 2007. It was mainly installed in the high-end vehicles like the Denali's and the Escalades. It was mated to the 6L80. Be careful with an L92 engine. They're great engines. However, the operating systems are difficult to work with. I do not like working with the early operating systems. There are several extra steps we need to take. The transmission in the 7 and 8s was also a little more difficult to work with. They had some codes and monitoring that would cause the transmission to go into a limp mode. Of course, we can take care of all that for you. However, it's just better if you can get a later motor. If you get the L92, it's a great motor. The L92 is an all-aluminum 6.2 VVT variable valve timing engine. In 2009, they took the L92 and they added flex fuel and called it the L9H. That's what I'm driving right now. It's an excellent engine. They continued production of the L9H right up through 13 or 14. However, it was overshadowed by the L94, which came in 2010. The 2009 L9H is all aluminum, VVT, and flex fuel. They did change a lot and upgraded the operating system in 2009. They went to a 455 ECM, which is a go-between ECM between the 384 from 07 and 8 and the 238 computer in 10 and newer. 2009 L9H changed the intake manifold to support the new map sensor. They also changed the injectors for flex fuel. So that means the intake, the fuel rails, everything on the top end of the motor is different than the L92. Now, it is the same upper end that the L94 runs. The benefit of the L9H is you can run any year L9H with the 10 and newer operating system, assuming you're running the later transmission. If you have the 09 transmission, run the 09 operating system. Do not run an 07 or 08 transmission in an 09 or newer operating system. You're going to have nothing but problems. In 2010, they came out with the L94. The L94 is nothing but an L9H where they added AFM, or 4-cylinder mode.